The model for the heat pipe is pretty straightforward. The setup of the definition's pretty easy. You put surfaces where it contacts the heat sink base that mounts to the processor, those faces, and then the faces where it's going to touch the vanes at the other end. Two resistor component, again very straightforward as well. Got the contact resistances in there, our inflow, exit at atmospheric, so pretty straightforward. Solve time's just under an hour. If we have a quick look, yeah, so under an hour for the standard ones. The refined one takes a few hours to run, I believe. But again, for preparation for the demo, I recommend loading each configuration and loading the results ahead of time, and you can even have the plots displayed on the other configurations, and just on the starting config have the plots hidden initially so that you go there and create it yourself. That way you can easily do the comparisons. But again, the result quality with the thin wall refinement is pretty amazing. We go to that final design, and you'll see again with the initial mesh we just got the default, and we've got optimized thin wall resolution on, and that's why it gives us such accurate results without having to have a refined mesh. And you can see here the mesh region we have is for the more refined model, and it's just a big block around the heat vanes there to give us a more accurate result. I've added some nice documentation. For example, some background on the Pabst fan that's actually in this device. We've got the data sheet for it, so that's the one we're using. We also have a data sheet on heat pipes. This is a very simple PDF talking in general overview about how they function, and it's sort of like, you can think of it as an extension of the excellent data we have in the knowledge base that Julian Bussa puts together. And I've got a fantastic PowerPoint presentation I found online which talks about the fundamentals of heat pipes. It's got incredible detail through the theory, the applications, the different ways they function, the limitations based on temperature and power out being transmitted. It's incredibly detailed. It even talks about the different designs and the different types of wicks that they have and all sorts of other things. So it really is a great little PowerPoint for you to take a look through, just to make you familiar with the different ways that heat pipes are utilized. So I think this should be a good demo to help again showcase two resistor component and heat pipes in the electronics module.